perfectly fine. We'll at least get started with our housekeeping items. If you can send me a confirmation that you can hear me okay, that is great, and we'll go ahead and get started here. Um, let's go ahead and get started with introductions. All right. Well, thank you so much. I do see a few people confirming that you can hear audio. So that's all I need, and we'll go ahead and get started. Okay. Well, thank you so much, everyone, for joining us here today. And today's webinar is hosted by the LIMS Forum. My name is Dinah Ramirez, and I'm your moderator for today's webinar. Today's webinar, A Guide for Management, Successfully Applying Laboratory Systems to Your Organization's Work, is part one of a webinar series that will be presented by Joe Laskowski. Now, before we go ahead and get started, I do want to go over a little housekeeping. Now, this event will be recorded and it will be available for replay on limsforum.com, and a follow-up email will be sent to everyone who registered here today. Now, Joe's content and his discussion will be about 30 minutes in length. If you have any questions or comments during the presentation, please go ahead and type them into the chat box below your screen. And Joe will take some time at the very end to address your questions. We'll have plenty of time for that. We also want to know who's with us here today. So go ahead and tell us who you are and where you're from in the chat box. You're also welcome to provide us with some more detail about your job role in the laboratory, or maybe even your interest in attending this webinar session here today. So while you go ahead and introduce yourself in the chat, let's go ahead and introduce our speaker here today. If you don't know Joe, Joe is an experienced laboratory automation computing professional with over 40 years experience in the field, including the design and development of automation systems, LIMS, robotics, and data interchange standards, and consulting on the use of computing in lab work. His current work centers on working with companies to establish planning programs for lab systems, developing effective support groups, and also helping people with the application of automation and information technologies in research and quality control environments. Now, we're excited to have Joe with us here today, so let's go ahead and check in with Joe, and we'll go ahead and get started. All right, Joe, thanks for joining us today. The floor is yours. If you want to go ahead and turn on your microphone, we'll go ahead and get started.
Very good. Can you hear me all right?
Yes, I can hear you loud and clear.
All right, great. Conversations about laboratory informatics can start in a number of ways. They can be hallway conversations, talking about issues that people are having in lab operations. They may also be the result of a demonstration that someone sees of a particular product that might look useful in a particular laboratory, like an electronic laboratory notebook in research, or a LIMS system in quality control. They also may be the result of conversations that have some contention to them. For example, IT groups and lab groups having different perspectives on things. IT groups might want to prefer use an ERP system, for example, instead of a LIMS. Regardless of what stimulates these discussions, it can mean introducing technologies that you and others are not that familiar with. You may be wondering about what these things do. Are they worth it? Do they really work, and can we really put them to use? And those are the kind of things that we're here to discuss. During these webinars, we'll also look at some issues that you may have heard about that can give you some pause. Cost overruns, scheduling problems, bad product choices, and what you can do to avoid them. As Dinah noted, this is going to be the first in several presentations. The technologies these conversations are about are designed to increase lab productivity, and also something that's becoming very important, the quality and integrity of the results. Basically, we want to be able to produce more and better results at a lower cost. But as in any environment, you've got to make sure you do the planning, you've got to make sure you choose the right tools, and then use them effectively. We're going to briefly identify what some of these technologies are before we go and look at them in a little bit more detail. The most common one that people encounter are laboratory information management systems. These are also referred to as laboratory information systems in clinical and healthcare operations. Their use is to help manage workflows and testing, getting test results in, logging samples, and carrying out those types of operations. Electronic laboratory notebooks are used to collect and manage data from research products and experiments. They're basically a diary. We've been using them for generations, but they've been paper instead of electronic form. Scientific data management systems help solve some problems in the laboratory dealing with a large number of files that are being generated. So it's basically a giant file cabinet that everything can refer to. Laboratory execution systems, a number of people may or may not have heard about, at least in those words. But those are systems that are designed to help make sure that testing protocols are executed properly and that all the data that's necessary is properly recorded. And they also carry out some other functions. And then we have instrument data systems, systems that automatically acquire and process instrument-generated data. They can save many hours of work, avoiding doing hand calculations, baseline corrections, peak measurements, for example, having all that done electronically. We're not going to go into a lot of depth in each one of these technologies. That would take a lot more time than we could spare. But if you're looking for more information about these things, support issues, and other points, this book might be a useful reference for you. This webinar series, including the session today, is going to look at introducing laboratory informatics in their application, the keys to successful implementations, issues about return on investment, choosing the right system components, how do you go about minimizing risks and regulatory issues, the support requirements, and then we'll also take a look at some developments that may be needed in the future. The points that we're going to cover today are whether or not there are real benefits in using these technologies. They're supposed to do a lot for us. The question is, do they really do it? And we're going to look at some laboratory environments, how laboratories work, what their workflows are, and then how these tools can fit into them. We'll begin by looking at some examples where these things have been effectively applied, and we'll look in two areas in particular: clinical chemistry laboratories and contract testing, labs that run their laboratories as a business. Clinical chemistry is an area where their success in using laboratory automation is by design. They've been very good at figuring out how to make systems work, how to make them work together. You'll notice the reference to laboratory information systems, again, the same as LIMS. But they're worrying about things, for example, in integration interfacing, leveraging automation for efficiency, and other topics. Now, one reaction you may have to that choice is saying, well, they're not like us, we're different. You'd be really surprised. Laboratories fall into classes of operations, and they have the same behaviors. The tests that go on in clinical laboratories may be different than what you have, but workflows are very similar. The problems that clinical labs had occurred in the 1980s. Clinical labs have contracts, annual or longer, for how much they can charge for each test. One of the problems they had was that their costs were going up faster than the income was coming in. So they had to go off and figure out a way of reducing costs to the minimum and still getting good test results out. It's a standard production problem. The solution was something called total laboratory automation. They took a community-wide approach to the problem. One of the things that's important is they did not go about this one lab at a time. Everybody didn't do their own thing, but they got together and looked at the problems they were dealing with and tried to find a community-wide approach. That approach resulted in the development of standards for both inter-system communications, for example, the laboratory information systems, talking to hospital record and patient care systems, administrative functions, and also standards for instrument communications, getting the data from the instrument into the laboratory information system in a variety of ways, but using standardized protocols for doing that communications. They also did a lot of work on education, making sure that the people working in the laboratories knew what they were doing. And that's an ongoing educational problem. And they also dealt with vendors. They made sure the vendors knew what they wanted, what the specs were going to be, and then asked them to produce products that would meet those requirements. And the results have been fairly impressive. Between 1965 and 2000, this data is a little bit old, but there isn't a lot available. 1965 and 2000, the consumer price index increased by a factor of 5.5. But over that same period, the productivity increase went up by almost a factor of 10. And the cost per test went from 79 cents down to 15 cents. So that's a fairly impressive number. In the Ohio State University, in a presentation that they did on their implementations of total laboratory automation, they did a lot of data calculations before and after total laboratory automation. And overall, they saw about a 70% improvement in productivity. Also talked to some particle testing laboratories and medical testing laboratories. In a particle testing laboratory, they said it's really important. Automation, they can't run their operations without it. In a medical and pharmaceutical testing laboratory, they said without laboratory automation, they need several chemists to be completely consumed by the workload, and their prices may be running 2 to 3 times higher than they currently are. They also pointed out, though, that automation can be very trying, but it's very rewarding if you do it correctly. It takes work. It's not easy. One biomedical testing laboratory that I spent some time with had a kind of an interesting approach to dealing with it. Before they accepted a contract, they completely analyzed the process that they were going to be using and broke it down, optimized it, and covered everything from sample submission through sample logging, processing, and reporting, making sure that they optimized each step and reduced the cost of the entire process before they figured out whether or not they were going to write the contract. So basically, they did a manufacturing approach to dealing with laboratory testing. So in each one of these areas, some common themes: standardization, education, planning, and they didn't just put solutions together, but the systems were engineered. Now we're going to take a bit of a look at how laboratories work, what the different environments are, and how the tools fit in. The most common laboratory tool is the paper notebook. We've been using those forever. They've got a table of contents, work pages, a signature block down here where somebody can sign the work as it came in, as they did the work, and then also have the work witnessed and dated. And you can put anything on paper. You can write text, you can enter results, drawings if they're appropriate, chart printouts from instrumentation, images can be glued into it, basically anything. But there are some issues with that. It's a generations old technology. It's still in widespread use. Many laboratories are still using these things. They're very effective at recording your thoughts and observations. They don't require electricity. Backup is a real problem. How do you back up paper? You can scan it in, you can make photocopies, but you're still working with paper. And indexing the information is difficult. There's a problem with knowledge and intellectual property management. How do you find things? What happens if people leave the organization and people start forgetting about the information that's available, that was put in those laboratory notebooks in the first place? Even though you made a large investment in that work, the value of that investment is going to drop off over time as people literally forget that it ever existed. Electronic laboratory notebooks can solve these problems. This is a screenshot from a company called LabTrack, LLC, and this is their desktop application. You can see they can put text in, tables, and charts. You can also link in third-party applications. The idea is that you can build the pages pretty much the way you would a document in Word, deciding where you're going to put text, where you're going to put charts, how it's going to be laid out, and how you're going to bring results in. These things are also available as web-based applications. The next couple screens are from Core Informatics, which is now part of Thermo Fisher. This is their inventory page, and allows you to get access to vendor products, purchasing information about instruments and their qualifications, documentation, looking for molecular searches. That same system can bring in information from a variety of products. This is from a web-based Microsoft Office application where they brought in tables and charts. They can also link in third-party applications for doing molecular graphics. So electronic laboratory notebooks can deal with a wide range of types of information depending upon what you want to deal with. They can also deal with bringing in instrument data. And in this case, the data was imported from a PDF file. Now, there's one caution when you're working with some of these systems and they do imports from things like PDFs. You look at the data and you might say, gee, I'd like to be able to zoom in on these peaks here and get some more detail. From PDF files, you can't do that. Basically, whatever is printed is what you see. If you want to see more detail, you have to go back to the raw data. So ELNs are a newer technology. They're gaining widespread use. Again, just like paper, they're very effective at recording your thoughts and observations. They can support mobile technologies. Backup is easy. It's electronic systems, you back up the files. And it really assists with knowledge and intellectual property management. You can take data from the electronic notebook, you can archive it, you can sort it, you can put it into hierarchical systems that can be searched, particularly if you're dealing with multiple laboratories or multiple campuses. So you get the productivity improvements include things such as improved record keeping, replacing manual input with automated entry, which is much faster, much more accurate, and lower cost. You don't have issues such as having somebody type a number in and then have someone else verify the number was typed correctly. You have shared access to entries as long as the appropriate policies are put in place, making sure that people don't get premature access to information that's in someone's lab notebook, and also allows for faster review and planning. And again, you get better return on investment because you can do more with the results. The information is, if someone leaves, it's not forgotten. It's indexed somewhere in the system. Where ELNs functioned as a diary of experimental work and thinking, LIMS are different. They're designed to support a process, and the two technologies are used in very different applications. LIMS are designed to deal with the workflows, then that's for routine testing. The diagram on the left is kind of a rough mock-up of the lab I worked in, the one lab I worked in. This is where samples came in and where sample preparation was done, and this is the instrument lab operations. The samples were dropped off here with the request sheets. We had no LIM system. It was manual. The LIM system was a woman by the name of Marge. She would take care of logging samples in, putting the samples on the shelves or in refrigerators, and then if we wanted to find out what was going on, it got to be a bit of a hassle. We had to go back to the logbook, look things up, which means only one person could do it at a time. Once we had a list of what work had to get done, then it was going off matter of finding the sample sheets, finding request forms, finding the samples, looking at historical data. Sometimes you'd recognize something and said, wait a minute, we did that test already. Finding everything was a manual system. Searches for infrared spectra, reference files were all manual. You kept on flipping through them. We had manual calculations of results, and when it came to priorities, everything was number one. Nobody had a level 2 priority. So a LIM system is designed to solve that by providing a database and a electronic process, a web-based process or a desktop process for logging samples in, checking to see if they've been received, generating work lists in priority order for analysis, entering data both electronically and manually, doing reviews and approvals and exporting results. And all of these things can be done simultaneously without people having to wait because someone else is looking at the logbook. So the LIMS system supports the laboratory testing process from sample login, sample processing, to the generation of results and the analysis work that had to be done with them. One feature that is in ELNs and also in audit trails is something, in LIMS systems, is something called audit trails. An audit trail is a record of all the entries that are being made into a system, plus any changes that have to be made to that data. So you have more confidence in your operations. Here, for example, someone typed a number in of 50.5 milligrams, and it was a typing error. It should have been 50.59. So if change is being made, okay, if a change is being made, the record has to be kept of who made the change, who corrected it, what the reason for the change was, and who witnessed that it was done correctly. These are things that are automatic and built in. They provide track backing on the data, and again, build confidence in lab operations. LIMS' role in improving productivity is to reduce paperwork, reduce operating costs. The first thing you can see is a reduction in labor and better use of people because nobody is sitting there at a table logging samples in. It's all done electronically. You have electronic transfer of instrument data, and it makes it a lot easier to find results, samples, work lists, producing reports, and then overall managing the lab's workload. There are also specialized LIMS. Even though the workflow is fairly classic in testing operations, there are specialty applications. For example, water testing, stability, formulations, and other things have standard protocols that they layer on top of a LIMS system. And there are laboratory information management systems that are designed to take advantage of that and work in these specialized applications. I believe there's also one specific for the wine industry. LIMS and ELNs can exchange information. Results can be entered manually or electronically via instrument systems. So we have a process that can go on. Everything from sample storage and preparation to instrument data through file management and the work that LIMS and ELNs carry out. This part of the process can be done automatically by instrument systems, everything from automated sample preparation to sample introduction, instrument analysis, and then data acquisition and processing. And this is fairly common. This section in particular is fairly common. Where things get hung up is often sample preparation. In sample preparation, you want to make sure things are done, particularly if that work is done manually, or if the entire operation is done manually. So we need some guides to help us make sure that each step is followed carefully, and this is particularly important in a regulated environment. The software that helps us with that kind of a system is a laboratory execution system. They're available as standalone systems, and their functionality has also often been incorporated in other informatics processes. They do not directly address productivity issues, but they do help build confidence in the quality and the integrity of the results because you have reports and tracebacks of how all the analysis work was done. When the procedure is started, the analyst who's doing the work is verified as being qualified for it by checking the personnel database. The equipment and reagents are tested or checked to make sure that they're qualified, that the equipment has been calibrated, that the reagents are current, and you're not dealing with out-of-date materials. There's a step-by-step execution process, and each step is checked off. Any instrument data is electronically imported, and then results are generated, and they can be sent off to a LIMS system or an ELN. So it provides a very rigorous approach to dealing with lab processes. These processes that go on in laboratories, and we've got a list of some of the instrumentation on the side, they generate large amounts of files and lots of documents that have to be managed. And that is the responsibility of scientific data management systems. As I noted before, it's basically a big filing cabinet. You can organize things by projects, experiments, by who the experimenter is, but basically it's a way of managing all the data that's generated by the laboratory, and then from there, that information can be sent to a LIMS or an ELN. So you have the sample preparation, the data generation, its management, and then its use. So we can actually put together a pretty nice picture that looks pretty impressive. Making that picture work is a different matter. One of the concerns you have to worry about is what technologies are suitable for different lab environments. You might say, well, I'm in research, so an ELN is obvious, or I'm in quality control, so a LIMS is obvious. But that's not always the case. You need to look at what kind of work is being conducted, what kind of processes are in place to determine exactly what the informatics systems are that you're going to be working with. For example, an ELN might be used in research, pure research, or it might be used in a testing and research support group. For example, this might be doing immunology, and this might be an analytical testing group or physical testing group. They may need ELNs, and they may be different types of systems, accessing different external databases, for example, and having different functionalities. LIMS would be used commonly in both this testing support and also in quality control. This testing group, for example, part of the responsibilities might be to develop new testing procedures that are sent over to quality control for operations. So you'd want this system and this to be very similar, if not identical. There's little need over here for an ELN in quality control because they simply don't do development work. They do processing work. Scientific data management systems and instrument data systems are widely applicable, but lab execution systems, again, have their specific applications. They may be used in research if there is a certain protocol that's going to be followed, and you want to make sure it's very carefully followed each time, and that the methods are updated as needed. The testing research group may use a lab execution system to define the procedures that they're working with, and then send those over to quality control for their execution. So again, the tools you use have to fit the requirements. Unlike LIMS, which has a core focus on a common process, ELNs do have to support a wide range of capabilities. And the term electronic laboratory notebook in the past has included things such as instrument communication systems by Lab Tech Notebook. Mathematica, which is one of the earliest electronic laboratory notebooks that's used for research applications in mathematics, has been around since the 1990s. SmartLab was the precursor to laboratory execution system technologies. It started off, excuse me. It started off from VelQuest and is now owned by Acceleris. And then there are also discipline-specific ELNs. So the first thing you need to do is define your needs and then look for the products. Simply just look at the names. When these technologies were developed, they were developed very narrowly focused. For example, there were text and document management systems. There were systems for test execution, the SmartLab system. Scientific data management systems and ELNs were separate functions. LIMS and instrument data systems were all very narrowly targeted functions simply because it was very early in the stage of doing the technology development. But as time went on, different vendors started looking at these functions and saying, well, having a LIMS and a test execution system makes sense, so we'll incorporate those functions into our LIMS. It may also be appropriate in ELN. And both of those may want to talk to instrument data systems. So what's happened is that products that were narrowly focused now have a large range of capabilities. So even when you're looking at a class of product, you've got to look at the details of what those product offerings are to make sure they're really suitable for what your laboratory needs. Another question that may come up is if you're using similar types of systems in different parts of the organization, do you need multiple systems, systems with multiple functions? Do you provide share access? This is really going to be more a function of your organizational and policies than it is the technology. Again, you've got to look at what has to be accomplished. If you want to use the same software between multiple groups, can those groups come together and actually come up with a set of requirements that they can agree on? It's a major planning operation, which is why the organizational aspect is important. In this session, we've introduced informatics, looked at some of the key components and where they can be applied. We've looked at where they might be used, and we've begun some ROI considerations. The next section is going to look first at ROI and then begin looking at the keys to successful implementations. So today is the first in a series of sessions, and we're going to be adding on to that series as we move through it. If there are any topics you'd like to see covered in future presentations, let us know. Just contact us. And with that, we can take questions. Are there any?
Okay. Thanks, Joe, so much for a wealth of information in your presentation here. And it looks like your presentation was exactly 30 minutes. So that's great. And I think we have plenty of time for questions if there are any. I believe that you can view the chat, but let's take a look at what some of the questions are. It looks like Jeffrey has maybe a part one of a question here. And it's, are lab execution systems configured or intended to be run by session? One session to many of the same tests, one to many, or be run for each individual test?
You can look at the lab execution system as a collection of scripts. So each test process would have its own script. And if somebody was going to go off and do some testing, they would call up that particular script, follow it, carry out the testing. Whether or not it's on a sample at a time basis or multiple samples at a time basis, basically depends on the equipment you have. If you have, for example, if you've got something that's robotically driven, they can do multiple samples if you're doing a microplate system. If you're using auto samplers, you can do the sample preparation, get it in the auto sampler, and then have it processed by the instrumentation. But basically, you can look at it as a scripting system that you have to follow. As to how many samples you can do at a time, that depends on how you set up the scripts, whether you ask for one data point or if you're looking for a range of data points.
Okay, great. Hopefully that answers your question, Jeffrey. It looks like Frank also has a question. How well can mobile devices or tablets be integrated in wet labs? Is it a good idea to have them next to dangerous chemicals?
Oh, well, yeah, you've almost answered the question there. You don't want them next to dangerous chemicals because you've got to be careful about what they come in contact with, so they don't wind up with something that's corrosive or something that'll blow up. So you've got to take normal precautions. In many cases, there will be things you can wrap around the tablet, for example, to protect it. So there's obvious cautions that have to be taken place. You might find some way of mounting the tablet, for example, above the experiment so you can see it, gain access to things with a touch screen, and have all the equipment below it. Now, tablets are a very interesting tool, or a very interesting question. For one point, most mobile devices have cameras in them, and those cameras can be very useful in the course of the work you're doing. If you're doing animal experiments, for example, and you want to take a photograph of the animal or some characteristic or some device, it's really useful. But many companies have prohibitions about the use of cameras within their facilities. So while a mobile device might be very useful, there may be a problem getting it in because of the cameras unless you do something to disable it, which almost seems like a crime. But so yes, they can be used. You have to take appropriate protections, but you've also got to make sure that the company's policies permit the use of mobile devices. Many of the systems, particularly ELN systems, are designed to work with mobile technologies.
Okay, great. Thank you, Joe, for answering Frank's question there. Dennis also has a question, and in case he misses the next session, do you have any examples or use cases of successful implementation of ELNB working in academic research environments? Change management from paper to electronic can prove challenging and have heard of low adoption rates of ELN.
Yeah, there's I can't talk about specific things because of confidentiality issues. They have been used successfully. There are a couple problems with moving from paper to electronic media, and the problems sometimes are not so much the ELN itself. The issues usually come up with training because you're going from one media to another, one which is free flowing, do whatever you want, to one which is more rigid, and people have to get used to planning and laying things out, and then being able to edit formats and add materials. So it's that kind of a change, going from paper to anything else electronic, tends to throw people off a little bit. So they've got to be properly trained, and education is a big problem. However, there is another issue that comes up, and that's a personnel issue. People become concerned in moving from paper to electronic media because of privacy issues. If you have a paper notebook, you look at it as being your notebook. You're told it's your notebook. But what's in that notebook really belongs to whoever paid for it, is paying your salary. Once it goes to electronic media, people can start worrying about, well, gee, can someone else look at my data? Can they take my data? Suppose they have access to it before all the work is finished and reviewed. Those are problems that can occur in shared systems. And those are, again, educational points. But they're also a matter of setting up policies that data, for example, can't be viewed unless it's released. So you may have a private area where people are doing work with their data and know that it's private. And then once it's released, it goes into another area where it's more public. So it's not just a matter of going from paper to electronic systems, but also making sure that the people in their education and the culture in the environment is receptive to it.
Okay, great. That's a lot to think about there. So Jeff also has another question here. Has there been any kind of push and success in providing a standard electronic delivery format when resulting back to the various hundreds of EHR systems?
What do you mean by EHR?
Okay, let's see if Jeffrey will type in, but maybe we'll move on to the next question while he types that in. Or I guess Camille just has a comment here. Perhaps these are best for discussion in future parts of the series, but what considerations should be made so the exact use of these different components are FDA compliant? Also, do you have any suggestions for a company considering writing a standalone software program for R&D to collect sample data from a group of experiments and analyze the data this way?
Okay, it's an hour. All right, as far as making components FDA compliant, the components are not FDA compliant. It's how you use them, how you select them, evaluate them, and the process you put them into that becomes compliant. And it's a little bit different in clinical applications than it is in other applications, because in clinical applications you can have equipment that is pre-validated for certain tests. But the whole validation, the whole FDA compliant protocol is a function of the kind of processes that you put in place. Systems validation, for example, documentation protocols. So the same piece of equipment can be used very well in a compliant environment, and it can also be used in a non-compliant environment, simply because of the way people manage it and introduce it. Again, that's part of the reason why the laboratory execution systems were developed, so that there is a rigorous process for carrying out testing, making sure that all the steps are checked off, that the people are qualified to do the work, that the equipment is qualified to do the work, and the work was done appropriately. So FDA compliance is a process issue, not a hardware software issue. But there are features in these systems that can help meet compliance requirements. Most of the vendors have been down this road, and they can provide you with documentation and scripts that help you meet not only FDA but also ISO requirements. Okay, Jeffrey, I see what you're talking. Jeffrey's referring to electronic health records. Yeah, the standards that are put in place by the clinical systems and hospital systems are a series of standards called HL7, and they've been evolving since the 1980s, and they look like they're a fairly successful system. They provide the communications methods for going from a laboratory information system to patient healthcare records, and also provide the instrument communications between the instruments, instrument workstations, and also the laboratory information systems.
Okay, great. So now that we got clarification on that, I think that we're good there. I don't see any other questions at this time, but I do know that Joe, you are welcoming any ideas, of course, for future parts in the series. So if any of you want to go ahead and comment on those, you can feel free to go ahead and do that in the chat. If there is something that you'd like Joe to speak to, he's more than happy to maybe include that or develop that in a future session. And feel free to, of course, email him as well directly if you think of something after today. Just want to check in and see if there are any other questions. I don't see anything else coming through. Hopefully I didn't miss any questions.
Here's one.
Okay, let's see here. Okay, so I think Felix has, I think this is an idea maybe for a future session. Maybe
Yeah.
notes around personal or personnel acceptance, training, policy, organizational change, management activities.
Yes, we're going to be actually covering that, starting to cover that material in the next session, which tentatively is scheduled for November 30th.
Yeah, I think that's what we're tentatively looking at this point.
Yep.
And then we'll be sure to, of course, notify everyone who registered for today's webinar about that upcoming session once we have that solidified, and of course everyone who registered for this session and attended. Okay, I don't see any other questions that are coming through. Okay. Joe, is there anything else that you'd like to maybe cover or address maybe before we go ahead and close out of today's webinar?
Yeah, there's a couple points. One, if you're looking for more information on this material, one of the problems is that, largely because of the internet, a lot of the information sources have migrated to the internet and nobody knows where they are. But the vendors are certainly providing a lot of information, but it's always biased towards them. The book that's noted in the beginning of the session is actually a decent write. I did it, but it's pretty thorough. There's also work that has been done by the ASTM. There is an informatics document which is a guide to choosing and working with an informatics system. It's basically an outline on how to go about it. And that is ASTM, and the designation is E as in Everett 1578-13. You can get that from astm.org. It's currently undergoing revision. Some magazines, Lab Manager has a lot of information in it. There are some European documents, Scientific Computing and Scientific Computing World. One of those, I think, is still being published. The other one's dropped. And we're going to be providing more information, sources of information on the landing pages once we get this put on the recording and the other supporting information on the website. We'll also be making PDFs of the files available.
Can you provide the title of that book once again, Joe?
Yeah.
Or maybe, I don't know if you have it referenced in your slides, maybe flip back to that.
Yeah, let me go back to it.
And Jeffrey asks if we can provide links so that it can be referenced after the fact, after we follow up. So what we'll do is we will certainly go ahead and put some links together and information after today's webinar, and it will all be available on LIMS Forum, and we'll notify you, of course, once that's available.
Okay. Looks like things are slowing down. So let me thank you all for your attendance, for being here. And if you'd like to discuss anything, send me a note.
Okay, great. Well, thank you so much, Joe, for taking the time to join us here today and present a wealth of information. I think everyone in attendance appreciated it. And I want to thank everyone who took the time out of their busy schedules to learn a little bit more about Joe's content here. So again, feel free to go ahead and connect with Joe at any point. And if you have any questions about the information he discussed, you're more than welcome to reach him. Thanks again and have a wonderful day, everyone. Take care.